So let's welcome on stage our friend, Marco Ippolito. Thank you.
Test. Okay. Hello. I know it's quite late, and I'm tired, and I know you're tired too, so let's try to make this as pleasant as possible. So today I will talk about, we talk about a lot of open source, and I'm an open source maintainer, and I happen to maintain a little project called Node.js. I don't know if you ever heard about it. And today I will talk a bit on how I integrated native TypeScript support in Node.js. So, my name is Marco Ippolito. I'm a member of the Node.js Technical Steering Committee. I also do a lot of releases for Node. So if you're using Node 20, it's probably released by me. And I also do, I'm also a security engineer at Hero Devs. So, let's talk a little bit about the history. So why TypeScript is relevant, why do we care about TypeScript, and like why. So this is a little, it's quite fun because this is the State of JS survey from 2016. This represents a snapshot of what the JavaScript ecosystem looked like in 2016. So we can see things like CoffeeScript, Elm, and ClojureScript, things that have disappeared. And there also was TypeScript. In 2016, looked very differently and had like very small adoption. For example, in this case, it had like 21% of people said that they've used it. And the majority of people, they haven't used it or they were not interested in using it. This has changed dramatically in the next 10 years. In fact, in this screenshot, we can see that in Stack Overflow Survey 2023, it was the 5th most popular programming language of all. And these are the download stats for TypeScript. It's per day, so it's 12 million downloads per day, which is insane. It's one of the most downloaded packages. So yeah, TypeScript is popular, and we cannot deny it. How many of you are JavaScript developers? Okay, a lot. And how many of you use TypeScript? Yeah, so TypeScript has become a standard in terms of usage, but not a standard in terms of language, and I will talk a little bit about that. Like, it's a standard to use that language, but it's a language without standards. But the issue was that on Node.js, we were getting a lot of issues and feature requests. Please run TypeScript. We want to, like, users just want to run Node file.ts. That's like, they don't care about loaders. They don't care about features that Node gave them to be able to run TypeScript. They just want it natively. And I understand that because it's a big improvement in terms of DX, but it comes with some drawbacks because of how TypeScript is supported. But one day, last year in July, I woke up and I decided to do this work. So the reasons why it didn't happen before, it's because it's very hard to get consensus on stuff. Like, Node.js is open governance. It's run by volunteers like me who are like, they do the work not because they get paid or there is a there is a backlog, there are managers. No, just for the vibes. So it's very hard to get consensus because people have different opinions on how to do things. There are very different stability guarantees between Node and TypeScript. So Node has a 3 years long-term support. So for example, Node 22 is now the active LTS. It will be maintained until April 2027. So as you can imagine, it's a big commitment. Well, TypeScript is very different because it does not follow Semver, so they can perform breaking changes on every minor upgrade. And embedding TypeScript into Node.js, it's not possible because it would mean to lock a TypeScript version for nearly 3 years. And that's not acceptable because the language changes so fast, and that the TypeScript that you run today is very different from the TypeScript you ran 3 years ago. TypeScript requires a config file. Node does not have a config file, does not want support config files in like other config files. This is not true because I've been working lately on creating a Node config file, JSON, so stay tuned. One big issue is that, okay, we cannot use TypeScript as a library. What do we use? And people had different opinions. Let's use ESBuild, let's use SWC, let's use Babel, let's use, I don't know, there are a million tools that do the same things. Each of them has different kind of pros and cons, so it's hard to just pick one that works. There were a lot of issues in terms of CommonJS CSM interoperability. This has been fixed very recently, like last week. We released Node 20.19, which make all the Node.js release lines fully interoperable. There is the full interoperability between CommonJS CSM. So there's a problem that it got fixed very recently. Also, source maps. When you transpile TypeScript, you need source maps to be able to reconstruct the location inside a file. And this is a big overhead. And it's not something that we wanted users to like, okay, we run TypeScript, but at what cost? That you don't know, like that you need source maps or you cannot debug your code. And finally, no champion. Like, nobody wanted to do this work because it requires to like talk with people and make all these things happen at the same time. And this was like very hard job. But I woke up one day randomly and I said, I'm going to integrate TypeScript in Node.js. And I opened a PR and it happened in 20 days. So I've been working since July of last year to improve TypeScript. So this is going to be a very long commitment, but it's crazy that it happened for no reason, just for the vibes. So my proposal was something called type stripping. So we take TypeScript and we remove everything that is not that can be erasable because it does not affect the runtime execution of the code. In this case, we have an interface. An interface is something that does not exist in JavaScript and does not affect the runtime, so we can just delete it, right? We can ignore it, basically. Then we have this type here, that it's labeled value. It's the interface that we used before. We can just remove it because it does not affect runtime. So we end up with this. This is valid JavaScript. We can execute it. Cool. So we can do that. And it's crazy that nobody, yes, the other runtimes were doing, but nobody thought about something that I will tell you now. So this is the end result. But as you can see, the location inside the file has changed because we have removed pieces of code, so now our file looks different. But is there a way we can try to preserve the location inside the file? Yes, we just put blank space instead of the syntax we have removed. And this is something that sounds stupid, but it actually works. So you don't need source maps because the location inside the file is exactly the same. And so this is why this approach worked in terms of source maps. So crazy. Also, we cannot perform type checking. The reason why is that TypeScript does not have a spec. So the implementation of TypeScript is the spec itself. So nothing else can do type checking other than TypeScript itself. And as I said, there is no compatibility in terms of stability, so we cannot embed TypeScript, and therefore we cannot perform type checking. Other runtimes can afford to embed TypeScript. For example, Dino has a Dino._check, and they embed TypeScript. The reason why is they don't offer stability guarantees as long as Node. Node has 3 years, Dino, they just released a stable release, but I don't know how long that's going to be supported. And Ban has, I don't know, like -1 stability. So not TSConfig, you don't need TSConfig to strip the types. Like we are not going to support all the kinds of different flavors of TypeScript. There are going to be limitations, I'll show you later, but the fact that we don't need a TSConfig is great. So we just removed inline types. Everything that is not an inline type cannot be removed. I will throw an error, and we will see that later. No source maps, great. And this is stable. So this was joint effort, because as soon as I opened the PR, like people swarmed, and they put me in contact with the TypeScript team. So we organized a venue where we could talk and see how we can like talk to each other and work on this together. So that's what we did. And they gave us the assurance that the transpilation part is going to be stable. So they're not going to break Node. And therefore, we can safely perform this type stripping. We used SWC. So the reason why we use SWC is a library that is widespread inside the ecosystem. We use custom versions that the creators of SWC implemented for Node. It's in WebAssembly. The reason why we could not use Rust or Go is because Node.js is a C++ project, and we build Node on platform like SmartOS and like PowerPC, BM proprietary stuff, and Rust does not support all the platforms that we use, so we cannot use Rust, or I don't know if Go does, but that was out of the question. It is battle tested. It is used in a different form by Dino. It's used by RSPack. It's very popular. SWC, it's a very popular package. They gave us type stripping support. The maintainer actually implemented the type stripping with a blank space in like 1 week. And so that allowed us to go very fast on the Node.js implementation. It is performant. It's very fast compared to Node.js with external loaders. And we got like a very nice support from maintainers. SWC is a project maintained by Vercel, so they decided to help us with this work. So I took SWC and wrapped it inside the package called Amaro, because of how bitter the whole thing was. And so we took this, we wrapped SWC. The reason why is that we wanted our users to be able to upgrade the TypeScript transpiler version independently. So you can use Amaro as an external loader, and is it also used inside Node Core. So if TypeScript releases a new fancy major upgrade, you can just release you can update Amaro, and you don't need to update your Node version. Another cool thing is that with Amaro, it enables to use TypeScript inside the browser, because Amaro is WebAssembly, it performs type stripping. So there is this package called module-shims2 that allows you to use TypeScript inside the browser. So very cool stuff. This enabled a lot of things moving the ecosystem. Cool stuff. So last year we released this new flag in Node 22.6 called experimental strip types. It does exactly what I explained to you. So it strips the types, and you can execute TypeScript files if they follow a certain subset of syntax available. It has some limitations, because there are some TypeScript features that are not erasable. They cannot be stripped. They require transformation or, as I said, code generation. The most common one are enums, TypeScript enums, and some kinds of namespaces. They require the transpiler to create some JavaScript code, because they do affect the runtime. Like enums are not erasable. They have a value at runtime, so you cannot erase them. And when they are transpiled, they become JavaScript. And this is what it looks like. Honestly, it's gross, and if you use enums, you should go away. But yeah, so a lot of people use this kind of features. So we also gave a chance to users to support these features. A cool thing is that not all, for example, namespaces, some of them are supported, some of them are not, because if namespaces export types only, they are supported because types are erasable. If they export values, they are not erasable and they will throw an error. So from Node 23.8, type-only namespaces are supported. But we created this flag called experimental transform types, which will transpile enums, which will transpile namespaces, will support everything, but it enables source maps, which means performance overhead and like use strip types, which is better. No down leveling. So down leveling means features that are yet to come in the TypeScript language, but are already supported by TypeScript. A common example is the using keyword, also called explicit resource management. This is a TC39 proposal in stage 3. So this is coming to the JavaScript language, but it is already supported by TypeScript. And another example are decorators, which are going to become part of the language, but are now transpiled by TypeScript. So TypeScript does polyfill these features. We don't want to polyfill because if our implementation is slightly different from the spec, and it's going to give breaking changes to our users, and we don't want breaking changes. So we just ignore decorators, so we don't transpile them. If they are supported by the JavaScript engine, good. If not, they will throw a syntax error, and they will be supported in the future. Another limitation is that historically, TypeScript forced us to use JavaScript imports, even if the file was a TypeScript file. This is because TypeScript thinks as, like it's easier for TypeScript not to check if the file is going to be a JavaScript or whatever. So they, when bundled, when transpiled, the file is going to be JavaScript, so they just use JavaScript. At runtime, the file, it's TypeScript file, so we need the right extension for the right file. An example is when you import foo from foo.ts, you need to explicitly say .ts. Because at runtime, that is a TypeScript file, and if you put JS, it will look for a JavaScript file. TypeScript allow this with allow importing TS extensions flag, but that did not allow emitting code or transpiling. So in TypeScript 5.7, they created a new flag that supported specifically our use case. So it's called rewrite relative import extensions. So now you can use the .ts extension, and when you transpile, it will change it to a .js extension. So finally, that's something that should have been there forever, in my opinion. But also, another limitation is that when you import a type, you need to use the type keyword. Otherwise, Node.js is not going to strip that kind of syntax, and it will fail at runtime. An example is if you specify that it's a type, Node will know it's a type, so it can be erased and will erase it. If not, it will be left there, and since in the file where it is exported, it is a type, so it will be removed. It will not find the export and will throw a runtime error. The final limitation is that you cannot run TypeScript node modules. The reason why is that TypeScript team told us not to. So if you try to, it will throw an error, error unsupported on modules type stripping. Like they want to discourage maintainers to publish TypeScript in their libraries. The reasons why is that VS Code is it's not going to like TypeScript files inside the node module, so because it's going to perform type checking. So if you have like 1 GB node modules with TypeScript files, it will go and look inside them, and this will have like very bad consequences. So they told us not to. And there are also some compatibility issue with like the TypeScript version that you use as a producer and the consumer. So in general, it's a bad idea. I'm working towards a future where we can publish TypeScript code, and we will be there probably next year, I hope. So Node 23 enables this by default, so you can just run node file.ts and it works. Nice. It's still experimental, so don't use it in production, but it's a huge step ahead, and this will become stable, hopefully, in Node 24. So all the headaches of setting up TypeScript, gone. This is funny because we also support syntax detection in Node. So this is some TypeScript code because it has the foo.string. And it's also ESM. So like Node.js, to understand this is a TypeScript ESM code, it has to do a lot of things. So what it does is try to compile it not run it, compile it, so to check if it's valid syntax. It's not, because it's ESM and it's TypeScript, so it doesn't work. If it fails, it will try again as an ESM module, which is not, because it's TypeScript ESM and it will fail again. If it fails again, it will strip the types, okay? It will remove the TypeScript, so it will be something like this with a hole in the middle because that was the type. And then it will try again as a common JS module, okay? And that is not a common JS module, it's an ESM module. It will fail and it will try again an ESM module, and now we finally got it. So this has a massive performance overhead because, as you can see, it has to compile a script for 4 times. Not nice. So you can skip all of this syntax detection by passing the input type flag and tell Node that it's a module TypeScript or it's common JS TypeScript. So this will skip all the steps and just go in the right direction. Okay, so raise your hand if you think this is TypeScript. No hands? This is not TypeScript? This is TypeScript. Yes, this is a type, okay? This is TypeScript. But this is also JavaScript. And if you run it as JavaScript, it will output false. If you don't believe me, do this in a browser. It outputs false because the angulars in JavaScript are lesser and greater. So this means there is, well, if you try to run this inside TypeScript Playground, it will output this, which is a fetch, because it will remove the types. So there is a difference, there is a syntax ambiguity between JavaScript and TypeScript. So that's the reason why you will never see TypeScript in the browser. And you will never see TypeScript standardized because of syntax ambiguity. They cannot coexist because they have different runtime behaviors. For example, in Node, if you specify the input type, it will execute the fetch. So it's fetching, but if you don't specify that it's TypeScript, it will return false. And this is fun, very fun. So all of this to say that this is a big problem for the JavaScript, for the TypeScript adoption as a standard, because it TypeScript is not really a superset of JavaScript for this reason, and it cannot be. So unless we remove all the generics, it's never gonna match. So TypeScript 5.8, they released an amazing flag called erasable syntax only. So now if you use this flag, TypeScript will will squiggle when you use syntax that is not supported by Node. And so you can say goodbye to enums, namespaces, modules, imports, all this stuff that should not be in the language because it affects the runtime. And this is the TypeScript, the tsconf that we suggest you to use for modern projects. So all the flags that we saw before. So what are the next steps? Keep working on this, make it faster, unflag it in .22. There are some things that are breaking because monkey patching in user libraries like TS Node and some other libraries that do nasty stuff. Also, we want to make it stable, so I hope that in Node 24 this will become stable. Please give it a try. If you want to get involved, we have bi-weekly meetings with the TypeScript team. So we talk to each other, try not to step on each other's foot. And we have a repository where we talk about this TypeScript integration. Fun fact, this was all volunteer work. So like when we talk about open source, this was a very long commitment and a lot of work. And the fun fact is that, as you can imagine, this is something quite big for the industry because it removes a lot of friction. and like I got a whopping $300 in donations. So that is a big incentive for a maintainer to work. I'm joking, like as I said, we don't do it for the money, we do it for the vibes, but supporting maintainers is something that companies should actively look into, because if there are no maintainers, there is no, like work is not free, it comes with a cost. So companies send money to projects. And thanks for listening.
Nice throw, nice throw.
So, anyone want to say something? Over there. You are a newbie on open source, is that right?
I have a question for Marco. So last week, Microsoft announced TypeScript Go compiler. Does this change something to your roadmap?
So,
Thanks.
I wish it did. The problem is that the erasable syntax only flag is only for type checking and not for emitting. If it was for emitting, we could drop SWC and integrate the new TypeScript compiler. But until they give us like blank spacing and all of these features that we need, we cannot migrate. Hopefully, I opened an issue on the TypeScript repository, and we will talk about this next week. So stay tuned. But yeah, high hopes.
Else? No, so I can give you the last trophy of the day. So, this is for you for being an open source champion.